So to start off, we have to talk about some basics here. And I'm going to go in the most simplest route I can, and that is assuming that you know nothing about electricity, and we want to wire up a couple switches. Well, the first thing we have, if you're in a residential application, you would use Romex, which I'm sure you're familiar with. This particular Romex is a 12-2 gauge, meaning, excuse me, that there are two conductors and a ground in this one. Some of the older Romexes don't have a ground or have a different type, but when you say two wire, they're talking about two wires and a ground. They also make, obviously, a 3-wire. This one's not stripped, sorry about that. It's flat, just like the 2-wire. The old school Romex for a 3-wire, sorry about bumping the camera. Here we go, there's 3-wire, black, red, white, and the ground. Even though there's 4, we call it 3. And just for the heck of argument's sake, here is a round 3-wire. He started making it 2. I don't know why. I don't really care why, because the price is the same. I want to move on to some basic ideas on how switches work. The first being, this is complicated now that I see it. I'm going to have to draw through the tripod. So you have your electrical panel, circuit breakers, a light, and a switch. Basic symbols. Power comes in form of a 2-wire to your switch, to your light. And what's really going on is the black wire connects to your circuit breaker, goes to the switch, and inside the switch, in essence, is a device like that. You flip the lever, boom, power comes over to your light, and simultaneously the white wire would come to here, and then you would join those two with a wire nut right here. That's as simple as it gets. Now, I have taken each and every one of those single location switches and turned them into, for all intents and purposes, a three-way switch. I'm gonna sit down at my workbench here, draw it 90 degrees to you, and then rotate the thing, because it'll just make everything faster. Again, with the panel, hopefully that's in view. Nope, scoot it down. Oh yeah, there we go. Okay. A 2-wire comes out, goes to a switch. This particular time, the switch is a 3-way, connects to another 3-way, then it goes to your light. In between these two 3-way switches are 2 wires called travelers. I call them Traveler 1 and Traveler 2. You have to always assume that there's a white. I shouldn't say assume, because we know how that gets us into trouble, because sometimes all kinds of crazy stuff happens. But the white comes along, wire nuts in this box, in a 3-wire, comes to this switch, wire nuts together with the 2-wire going to the light. So from now on, I'm not going to talk about the white wire. Unless I talk about it specifically, you need to know that it's there. So there's, according to an old guy that taught me, didn't teach me everything, but he taught me quite a bit. I'm sorry, let me turn this back this way. He claims that there's 27 different ways to wire a 3-way switch. Now, obviously I just showed you one, and I'm sure there's, well, I know of at least 3 or 4, and it really depends. I think there's only about 2 ways to wire a 3-way switch. The way I just showed you, and then the way I'm going to show you, but in between those, depending on where your light is and where the power source is, I mean, there's they're different, but they're the same. So here's another one, just real quick. This one I call a down and back. Let's put the light right here. So let's say we go from the breaker panel to the light first. In this case, we're going to hook the the white directly to the light fixture. We're not going to hook the black, otherwise the light's on all the time. You might do that if you have a pull chain or a remote control or something like that. But what we're going to do is we're going to bring this hot, even though the cable goes from the panel to the light box, we're going to run a 2-wire to here, okay? So now we're taking power back to the switch. We're running our 2 travelers again, and then we're coming back this way. Oh, that got crazy and messy. To the light fixture. So current flow goes this way, either through traveler 1 in this drawing, and the light would be on. You flip either switch to the other position. Now current is coming to here, and it's got nowhere to go, so your light's off. Flip this one, light's back on. That's the premise of a 3-way. I'm sorry if that's review for some of you, but I feel like I need to incorporate everything. So this particular 3-way is in fact what I call the second way to do it. The switch part of the 3-way is the same, so we're going to draw that in. And we're going to show it in this position. Now, rather than having 2 travelers between the 2 points that have this in common, we're going to run a single traveler between the 2 commons on the switches. And then we're still going to have 2 travelers in this drawing. We're going to have 2 travelers, but this one will go to the breaker panel, and this one goes to the light fixture. Now, that's kind of crazy. That would be one of your 27 ways to do it, but let's look at it. Current is coming this way, it goes to both switches at the same time. So you have a hot at both ends. Comes through this throw of the switch, comes around to here, and now it's on the light. So let's throw this switch over here in this position, and sure enough, power comes to here, it goes to both switches, but it stops. It doesn't go anywhere else. So the light is now off. Go ahead and throw this switch the other way, power comes this way, and now it runs back around through this part to the light. Now, why is this important? Well, the guy told me that back in the day when they were doing knob and tube wiring, they could save on wire by not actually running 2 wires between the switches, the 2 travelers. So by going with the single traveler, come back around, T1, okay, you could, for instance, have your breaker panel and you have a circuit and it hits a plug and blah, it hits a bunch of other stuff, and it drops over here and brings, brings power to here, and then you continue on and you got another plug here, and this plug also comes to here. So you already have a wire between this end of the room, building, whatever you want to call it, hallway, stairs. You have a hot. That same hot comes across and does other things, but now you have, instead of a wire going between here and here, that wire's now up here. So you don't have to run 2 wires between there. You only have to have the hot at each end. Then you go back to a single, I guess it was a traveler. Technically it's not a traveler, but to some senses it is, because this is really the only traveler. This is more of what we call a switch leg. That's SL, indicating it's the switched part of the circuit that goes to the light. So now this light works also, even though I don't have the wire between here and here. Again, why is that important? Well, here's why. On my relays, on my home controller in the long, tall cabinet with all the RB5 relays, I mentioned I have a 3/4 inch conduit that comes from the panel to the control panel. The control panel, CP, okay? And that has multiple hot wires in it. For instance, I have one circuit that runs the lighting on the first floor north and one circuit for lighting on the first floor south. I have a lighting circuit for the basement, lighting circuit for the exterior. So I've got 4 circuits right there. So rather than running a bunch of separate circuits back to my control panel, I can bring my hot or hots to each point. Now, I have a switch in my room that used to be just your regular old single pole switch. I've replaced that with a three-way switch. I bring the hot to here. There was already a hot upstairs in the, I've already screwed up. There's already a hot from the old switch. So this is, let's do a do-over here because I screwed that up. So sorry. So main electrical panel, control trough box with multiple hots. Back to the original switch that's been removed. It's now a three-way switch. The hot that was there, and I don't care how it got there. Maybe it came from lights, let's say first floor north would be the bathroom and the kitchen. And that hot somehow runs through the walls, and it makes no difference whatsoever how it gets there. What makes a difference is, sorry about that camera bump again, that the hot goes to that terminal, okay? This is on the first floor. The control cabinet is in the basement. Inside the control cabinet on the RB5, there's actually 1, 2, 3, 4, 5, 6, 7, okay? Down here we have plus and minus 12 volts. So I throw my signal from my Arduino and the relay flips, and then there's a relay in here, okay? This is common between here, so they call that normally open, and between this one, which is labeled normally closed, which is basically exactly like this. This, although it's not normal, in this particular position, if the switch comes out of the box, we would say that right now, here, normally closed, here, normally open. And then the same thing on this side of the relay. And then when it's energized, it flips to the other side, closes the circuit. Why is that all important? Well, here's why. Because my controller, or my scheme of how I designed this whole thing, I could have done a bunch of different ways. But in order for me to know through my web interface that my light is actually on, I could put a current sensor on it, which would probably be the most accurate. Then I'd have to take that reading and know that, I'd set up parameters and all this and that. And the reason to be most accurate is, for instance, I can control a ceiling fan. If the fan is off by the pool chain, I'm still going to show the indication of whether power is going to the ceiling fan box, whether the switch leg is energized or not, but it's not going to really tell me whether the fan is spinning. Now, for me, I don't really care, because if I can use a little reasonable deduction, I could say, if there's power at the box, the fan is on. Whether if a fan speed control is high, low, medium, I don't care. The fact that it's on is all I'm really concerned about. That's this particular application. Other applications, it's important to know how much, blah, blah, blah. I'm not getting into that. So I know that the ceiling fan is on when I have voltage applied to the fan. Let's put the fan up here in pink. Let's get rid of pink because it's hard to see. Simultaneously, below all the stuff that you've seen in the photo, there's a control box that has 36 outlets. Let's review outlets real quick. On a regular standard household outlet, this is the symbol. And on both sides, there's a little tab. Below the tab is a screw. Okay? And if you break this tab, you run a wire to that screw and it energizes this portion. You run a second wire to this screw and it energizes that portion. So that's how they end up with a switched outlet. Or I should say an electrician would call that half hot. If this one is hot and this one is a switch leg, that's half hot or half switched, however you want to look at it. So the control box below the circuit board box has 36 outlets in it. I'm not going to draw them all. So what I did is I take this RB5 and I take the two outside wires, normally open and normally closed, and common. We're going to draw it here. Between the control panel and the switch box, up here on the first floor, circled as first floor, I run one wire as a traveler, T1, okay? Then I have my hot already on my first floor from the existing switch. This conduit from the panel comes to the controller. Now we're just going to kind of add it over to here. That comes to this terminal, so I don't need the wire. And I take, along with this wire, I run switch leg. And this old switch leg goes to the light. And now down in the control panel, this new switch leg tees off and comes to this receptacle. I take a USB charger that I bought a bunch of. I thought I had them here under my desk. I don't. And I bought USB ends, made up my own cables. So the USB charger is plugged into, there's not 36, there's 34 of them. We can get to that later. Plugged in here, here, blah, 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 blah. Wire goes into my Arduino input board, comes around on the other side. That happens to be a pink wire, so we'll go back to pink. And it goes to the terminal strip with all those things, right? So when my switch is on, my light is on, and that's up on the first floor, and my receptacle is on, making my USB charger on, sending me 5 volts over to my screw terminal. Then I go through the, that's the wrong symbol, I go through my resistors to create a voltage divider so that no matter what this output on the USB charger is, whether it's 5 or 5.1 or 5.3 or 4.9, I do not want my Arduino getting more than 5 volts. So I put this voltage divider on, which takes it 5 down to somewhere around 3.5. That goes in as the input on the rat's nest black wire. Then, when there's no power to the USB, I get a 0 volt coming in, and this voltage divider now acts as a pull down resistor so my points don't float on my inputs. That is taking a single position switch, most commonly in a small room like a bedroom or a bathroom, and turning it into a 3-way operation, but it's still, so the redundancy part that I was talking about in my post is that this switch that's in the room will always function as a light switch. Now, single location switches say on and off, or if you put them in upside down, they say NOFO. A 3-way switch has no lettering. A 4-way switch has no lettering. And that's because if it's up, it could be on. You know, top of the stairs, bottom of the stairs, switches get, you know, if you're anal like I am, sometimes you want them all to be down, to be off, and then, you know, just kind of craziness. But the fact that this doesn't have letters on it doesn't make it not function as a single pole switch. If my Arduino takes a crap, or I lose this power supply, or anything in the control panel aspect goes haywire, my switch still functions. That was one of my primary objectives. I don't know who's going to buy this house. I don't know if they're going to be, I don't want to say tech savvy because I'm certainly not tech savvy. I'm more hardware savvy. But should they have problems down the road after living here for a couple of years, I want them to be able to operate this house without an issue. That's why I did it. Now, to make things even more complicated, when you have an existing 3-way switch, am I right in the back? I'm not going to, excuse me for a minute, I'm going to grab some more paper. It's just out of sight here. Thought I had enough. Let's make this even more complicated. Let's go back to the original idea of a 3-way switch. Okay, and this goes to the light. And I'm just going to label this hot. No matter how it gets there, I don't care. Travelers 1 and 2. And let's say that So I want to make sure you understand that this is the actual physical switch. And I'm going to call this one top of stairs and this one bottom of stairs. Everybody's familiar with that. How do I take that and turn that into a standalone function and make it be controllable by the Arduino? Now I could have used the RB5s, but I chose not to. I chose to go with an ice cube relay. And by that I mean you may have seen them. They're little clear relays. This particular one is a 3-pole double throw ice cube relay. Who cares why I got its name? Rather than the RB5. I don't have an RB5. They're all in use at the moment. They look similar to this, although this is a timer. Get into that when we get into the garage. All right, back to what's important here. So now I want to what I'm really trying to do is take my 3-way switching system and turn it into a 4-way switching system. Again, so let's say we have a really long hallway. Here's my physical switch, and we'll call this left. And we have some office doors along the corridor, so we're going to call this center. And we're going to call this one, this switch over here, the right end of the hallway. Door from the outside, whatever, it doesn't matter. You understand the concept. Now the 4-way switch, so in one way, the switch throws an X. Flip the switch either up or down, then what happens is it goes straight across. Okay? Let's go back to here. Let's draw our Traveler 1, our Traveler 2. This is also Traveler 1. This is also Traveler 2. And that's really because drawing that to the hot, this to the light. I guess you could call it Traveler 3 and 4. Who cares? But as we look at this right now, the current is flowing up through the top Traveler, zigzagging down, coming across the bottom Traveler, and the light is off. We've already discussed why flipping either end works, but let's look at the middle. When we go from the black X to the straight line red, the current would flow through the red, come across, and our light's on. This is awesome. Now, what this really means is we can add as many of these crosses and X's as we need to through a really long hallway, or a particular area that has lots of doors and you want to be able to turn the light on every time you enter or exit a door. Even though it's called 4-way, the implication is anytime you have more than 2 switches, you need a 4-way switch in between. So you can have 8 switches. They're not called 8-way switches. They're a 4-way switch. All right. Next video. This is getting long, and I'm really sorry about it, but it's kind of important if you want to understand what I'm doing. So now, let's go back to my particular upstairs, downstairs situation. Oh, I can't do that. How did I? Gosh, I'm sorry. In the middle, the ice cube relay, it's really this 3 times right next to each other. Like this. 1, 2, 3, right? Inside the ice cube relay, and then there's a coil. And when the coil is energized, on mine, it's 12-volt DC coil. Coil energizes, then all 3 of these simultaneously flip the other direction, acting very much like a switch, which is what we did on that other drawing. So now, in order for me to have my receptacle in the basement that has the USB charger plugged in, I need my switch leg down here, and I need my switch leg up here for my light. I'm sorry, I'm drawing different symbols for lights, but you'll figure it out. So to do that, we have to bring, in my case, the one Traveler all the way around. It has to go between point A and B, and that's completely hard to figure out, but it's possible. I did several times. I'm going to redraw this in the middle. well, no, I'm just going to put ice cube here, right? Ice cube. So the tricky part about this was, and it took me a long time to figure this out, I was trying to come from here to my light and here to my light. I'm sorry, from here to the light and from here to the basement outlet. And it didn't work. And I made probably 15, 16 drawings, and each drawing was a different current path. And what I realized was that if I put a four-way in the middle, just like the other drawing, and I took both the receptacle in the basement and the light in the basement and had it on the same side of the four-way, it didn't matter. But when I picked opposite sides of the four-way, it didn't work. So in order to take this ice cube relay, let's try blue, we haven't done that yet, this ice cube relay, and turn it into a four-way switch, it's a little bit crazy, but when you understand what the four-way is actually doing, I got to go to another sheet. What the four-way switch is doing, crossing is one set or one throw. Let's call this, here, let's make this easy. Let's say that when the switch is up, it does that. And when you flip the switch down, it does this, okay? So if I look at this particular connection is the same as this one, right? And it connects to either here or here. And this particular connection connects to either here or here. So you have to kind of break this apart in layers. If you're a Photoshop person, you'll get the layer thing. And we realize that this is the same. This and this looks like a three-way switch, because this one here can either throw to here or here. It can either throw here or here. Then you have the same situation here. So basically you've got two three-way switches right next to each other on this particular thing. And they're always going to go at the same time. Meaning if you energize the relay or de-energize the relay, it doesn't matter. They're either going to be both solid lines or both dotted lines. There's no other way for it to happen. So to take a the ice cube relay is a 3-pole double throw, meaning it can only throw here or here. And as I showed in that last drawing, there's actually 3 poles. This would be pole 1, pole 2, pole 3. In this particular case, we abandoned pole 3. We don't care. If you were going to buy relays, you might want to buy exactly what you need rather than have an extra pole, paying for an extra pole. Sidebar. The RB5 actually is a double pole relay. I didn't have the space to do it, and so I went with the ice cube relays where I have existing 3-way conditions. To turn this into a 4-way, you need to imagine I'm going to draw this a little bit bigger, your ice cube relay as such. And we're going to connect this pole. How am I going to do this? Let me think about this out loud. You have to wire this pole back to that common, and this pole back to that common. I think that's right. So that you get this crisscrossing action. That might not be exactly right. I'm trying to think of what I did on the RB5. My RB5, or not my RB5, my ice cube relay plugs into a socket base like this. These are all my connections. Coil voltage, the common pole, and the throws. So what I had to do, I had to run a jumper from here around to here and here around to there, which is basically what this is. But what it allows you to do is take a relay that has 2 actions, energized or de-energized, and turn it into a 4-way switch, which gave me the ability to come from let's turn this into a three-way looking type thing, right? With a four-way in the middle. La-di-da. I was able to have my hot from my circuit electrical panel coming to this pole and this pole. Also from a different direction, this pole. So these are all three hots. Then this terminal and this terminal, which is really over here, right? It's not a four-way switch. Or it could be a four-way switch. It depends. I was able to tie these two together and bring this down to my receptacle and simultaneously get this up to my light. Now, I've been freakishly thinking about this for years, made wiring considerations in the wall, and by that I mean gone from my switch box just down into the basement with a piece of conduit, no wires, not like the wire I showed you, the Romex, so that in the future I could couple onto that, take it to the control panel, add the wires I needed, the colors I needed to get it to work. I'll double check this and make sure that it's right as far as the way that you have to tie things together, because it is a little bit tricky. I do have it drawn somewhere on my stuff, but this is what I did, and that's why I did it, and it's been very effective. I'm going to stop this video, make another video, and show you on the screen what actually happens.